Okay, let's take a look and see what we did in class today. So here's today's lesson. It's a little bit more about just kind of processing the idea of what a significance test is for proportions. So we'll start off, kind of walk through the lesson. This is a little different than we did in class. You all did it for me. I'm going to kind of use a calculator to do a lot of the work. So a local engineering firm had to conduct a series of layoffs recently. The company has 180 employees that could be laid off, and they will choose 10. All are equally qualified, so the company decides to use a lottery system to be carried out by the manager to decide who will be laid off. The manager posts a list of employees to be laid off. 5 employees are women and 5 are men. One of the women claims this is gender discrimination and starts a lawsuit against the company. So how could there be gender discrimination when half of the employees were laid off were female and half were male? What additional information would we need to evaluate the situation? Well, as we discussed in class and people came up with, we need to know how many total men and women are there? How many total men? How many total women? Okay, so what I told you in class is we find out that there are 120 men and 60 women. So if you think about that, that means there are 180 total people. 180 total people. And we're going to find out that 2/3 are men, 1/3 are women. So now if we think about it, do we think there's gender discrimination here? Is it likely that we would have 50-50 when there are twice as many men as women? So how can you use this simulation to investigate the gender discrimination claim? Detailed processes that could be used. We could do a lot of things. I mean, we could use our calculator and we could do the rand int thing. And we could do 1 to 180 and pick a person. And we could say, you know, 1 to 60 is a woman. 61 to 180 is a man. And we could repeat that process 10 times. And we could count, you know, how many there are. Another one we could do, use a dice, use a die. If you think about the die, there are 6 sides to a die. What we could do is we could pick 2 sides for women, 3 sides and 4 sides for men. So we could do a die where we could say, you know, 1 and 2 are women, 3, 4, 5, and 6 are men. And we could roll the die 10 times. That's another one. So there's lots and lots and lots of different ways we could do it. So what I'm going to do is, I mean, I can show you what it was like. Basically, if we were to do a die, I mean, seriously, if we're going to do a die, we'd say, on the camera, that's a man, 1 man, 1 woman, 1 and 1, 2 men, 3 men, 4 men, 5 men, 5 men and 2 women, 6 men and 2 women. That would be 7 men and 2 women. That would be 7 men, 3 women. So we ended up getting a p-hat of 3 out of 10. So what we could do is we could repeat that process. What I'm going to show you is in the calculator how we can actually do that. So you don't need to know how to do this. I'm just going to show you a quick way that the calculator can do this. So I'm going to go to the table, and if you think about it, this is a binomial setting. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those are all of my outcomes. There, I could get 0 women, I could get 1 woman, 2 women, 2 women, all the way up to 10 women out of 10. So what I'm going to do now is I'm going to go up here to the header, and I'm going to use the following. I'm going to do second vars, and I'm going to use binomial PDF. That's our exact value. 10 trials. Probability of success is 1/3. And I'm going to tell it to go look at the L1 column. So what's going to happen is when I do that, it's going to, every single one of these, it's going to figure out the probability of getting exactly one of each of those. So when I do that, bring it on down so you can see it. It shows me all the individual probabilities. So here is the probability of getting exactly 5 women out of 10. It's a little over 13.5%. So just the probability alone of getting 5 women is about 13%. So now what we want to do is let's take a look and try and figure out how often we ended up with half or more females being laid off. Well, if you do that, that's basically the sum of these. So if you end up doing the sum of 13 and 5.6 and 0.016 and then 0.03. So basically you're looking at a probability there of about 19, 20, a little over 20%. So there's about a 20% chance. These are all the individual probabilities. Now, again, we can do it in the calculator. We can figure out the calculator in a second quick. And we can do 1 minus 4 or less. So 1 minus 8 bars. I don't know, CDF, 10 trials, 1/3, 4. And what it says is about 21%. So there's about a 21% chance that I could have laid off 5 or more women. So in terms of looking at this from a gender discrimination perspective, when we looked at that probability we came up with, we're going to come up with a different one, but the one we came up with is like roughly 21%. So what we're saying is, if we're saying, assuming people were randomly chosen, there is a roughly 21% probability of laying off 5 or more women. So in this case, while there was twice as many men as there were women, even though we did 50-50, it's not a significant result. And this is the kind of thing that would actually be calculated if this was like a real lawsuit. They would actually go and would do things like this, and they would try and figure out the probability. Now, I mean, it's 20%, so it's 1 out of 5, once in a school week, kind of the likelihood. So that's the idea we're dealing with the significance test. And that's called, what we did there is really called the p-value. This number 6 is our p-value. It's the probability that we get the result we got or more extreme, assuming that the claim is true. And then this claim, the claim is that, hey, this was not gender discrimination. Everybody was put in a hat. It was truly, or it was a random process. So that was kind of what we talked about in class today. On the backside, kind of want to walk through some of these ideas so we have it. Factinate claims that 84% of teenagers think highly of their mother. To investigate this claim, a school psychologist selects a random sample of 150 teenagers and finds 135 that think highly of their mother. Do these data provide convincing evidence that a true proportion of teens who think that highly of their mother is greater than 84? So what we talked about last time is there's a null, there's an alternative. The null is always going to be an equal. The alternative is going to be something else. We're talking proportions, so I'm going to say P naught. Both of these will be P naught. The claim is 84%, so 0.84. So there's my claim. The words in here say greater than 84. My alternative is 0.84. So now what we have is we're claiming that it's 84. We're trying to do a test to see if it's greater than 84. The school psychologist performed the significant test and obtained a p-value of 0.02225. Explain what would it mean for the null hypothesis to be true in this setting. If the null hypothesis is true, it is saying that the true proportion of teenagers at this school is 84% or less. Technically, that's what it's saying. That's if the null hypothesis were true. Is at 84%. Let's just stick with as at 84%. Interpret the p-value. Okay. This is a phrase, assuming the true proportion of teenagers who think highly of their mother is 84%. The probability I got my observed result. And if you think about it, what is the observed result? The observed result is the p hat equals 135 out of 150. So this is a 90% one. The chances that I would get a 90%, I got my observed result are 0.0225. So there's about a little better than 2% chance that I would get this 90% as a proportion if the real answer was 84. So what conclusion can I make at the 0.05 level? Since my p-value of 0.0225 is less than my significance level alpha of 0.05, I'm going to reject the null hypothesis. I'm going to reject the null hypothesis. There is evidence to support the claim. The proportion of teenagers who think highly of their mother is greater than 84%. And really what I did is I just pulled that from right here. Your proportion of teens who think highly of their mother is greater than 84. So because my p-value is less than alpha, again, the thing we talked about in class again today was, just get a different color. If your p-value is less than alpha, we reject the null. If your p-value is greater than your alpha, we fail to reject the null. So that's the decisions we make. So in this case, since it's less, we're going to reject the null. We're not going to say that we believe it's something greater than 84%. So that is kind of what we did in class. I'm going to do another one where we're kind of talk about one of the practices. Hopefully that helped.